So I hope you all are fine. I'm Natasha and welcome back. So today we're going to continue our chapter number 1, and that is sets. So yeah, in the previous video we discussed about Venn diagrams, and in this video we're going to discuss about a new topic, that is union of sets. And one more topic that we're going to discuss with it is going to be intersection of sets. So let's get started. So first topic which we're going to discuss about is going to be our union of sets. So let me just write them let me just write it on the board. That's going to be the main heading for now. So what is it? It's union of sets. Union of sets. Okay, so in union of sets, what does that mean? What is what basically this is. So, and yeah, why are we, why is this is it important in sets or what? Okay, so first thing is that, let's take an example, okay? We have set A and set B. So in set A, we have elements 1, 2, and 3. And in set B, we have, let me just say this is set A and this is set B. Yeah, that's good. Okay, so in set A, we have 3 elements, and that is 1, 2, and 3. And in, set B, we have 4 elements, and that is 1, 2, 4. Okay? So, or maybe let's change it a little bit. Like if I'm going to say, I'm going to say elements 2, 3, 4. Okay. So in set A we have 1, 2, 3, and in set B we have 2, 3, 4. Okay. So you'll be a little bit confused. Like I'm just saying it orally. So I'm gonna write it on the board. So, but just before going to the example. I'd like to say a small definition, small statement for union of sets, and that is a set containing all elements, that are in set A or in set B. Set A or in set B are going to be, it is basically going to be the union of sets. Okay, so that's what I'm going to write it on the board there. Then we're going to, see that example. Okay. Okay. Yeah. So a set containing all elements that are in set A or let's say or in set B is it's called union of sets. It's called union of sets. Okay, sets. Yeah. Okay. So set containing all elements that are in set A or in set B. Basically going to be the union of sets. Okay. So let's take an example. So, for example, I'm going to take it, that one, which I just told you right away. So, yeah. So, set A, which has elements 1 and 2. Okay, I'm going to change a little bit the elements, And in set B, we have, in set B, we have elements 2, 3, and 4. Okay, so in set A, we have 1, 2, as elements, and set B is equals to the elements 2, 3, 4. Okay, so in union sets, like a set containing all elements. So so a union of sets is basically we have to write all the elements once, that are in the sets that are given to us. So we, 2 sets are given to us, A and B. For now, 2 sets are given to us, that is A and B. Okay, and in set A, you can see that 2 is, and basically these 2, they have one common element. Okay, so they have one common element, which is going to be the intersection of sets. But intersection of sets we're going to actually discuss after the topic of union of sets, okay? So like this, let's just forget about it. So I just told that we have to write all the elements that are in set A and set B. In set B, like we're only going to write all the elements once, okay? If they're repeated like more than, if they're written like twice or thrice or more than that, we're going to write it only once, without any repetition of the elements, okay? The same element that we have. So you can see that. So like basically, if I'm going to say that A union B. So first of all, we have something in mind. That is there a symbol for union of sets? Of course it is. It is like, the symbol of, the symbol is actually kind of like, this. It's like U, but it is like in the small u. Okay, so, don't get just confused. That is it a universal set? No, it isn't. It is u. So I hope you can, understand it. And let's just don't get confused. So let's just continue. Okay, so set A. So A union B is equals to the elements. What following elements will write? It is first is going to be 1, then 2, then 3, and then 4. As I told you, no repetition of the same element. We're only going to write it once. So A union B is equals to the elements 1, 2, 3, 4. That's what we have. So and in Venn diagram, in type of Venn diagram, we're going to have it like, this way. Like we have set A and we have set B. This is set A and this is set B. And the universal set is like all of it. Shaded part, okay? Like this is a shaded part. So it's like all the, all that portion is going to be actually the, what? A union B. Okay, so, So now next we'll have is going to be some properties, some properties that we'll, look after it. So we're going to look for some properties that we're going to have. And, So let's continue. So we have some properties for, the operation of union. So, properties. So like we have 5 properties. Basically, we have only 5 properties. So let's just discuss them. So properties of the operation of union, okay? Have a look. Okay, so the first one is going to be that, Okay, so first one is actually going to be that A union B is equal to B union A. So first property we have is set A, A union B is equal to B union A. So which means, and it is from commutative law. Got it? Commutative law. It's true commutative law that A union B is equal to B union A. So if I'm saying that, A union B is equal to the elements 1, 2, 3, 4. So this means that B union A will exactly be the same. Okay? Yeah. So now our second property that is gonna be a little bit like, Okay, it's like this form. So A union, then union of B and C, and they're like together. I'm just gonna tell you. So let me just first write A union B, and then their union, then from C. Okay, so this property, the second one we have is from, is through associative law. Associative law, got it? It's from associative law. So what we have is like A union, and then, A union, B union, and C. But, union of set B and C is going to be, compared from the set A. From set A, let's take a small example. Okay? So, for example, let's take set A as, this one same, okay? But this I'm going to add set C, okay? Set A is equals to the elements 1, 2, and set B is equal to the elements 2, 3, and 4. and set C is equal to the elements 1, 2, 3, 4, 5, 6. Okay? Yeah, so that's what we have. So we have 3 sets, set A, set B, and set C. And like first we have A union and then union of B and C with it. Okay. So first of all, set A we have is 1 and 2 in as elements, and set B we have. Okay, so first of all, we're going to see the union of these 2 sets. Okay, so union of these 2 sets are gonna be like let me write it. Okay, so it's going to be 1, 2, 3, 4, 5, and 6. No repetition of any element. Okay, just we're gonna write it once. That's it. So now the union of these 2 sets. So what is it going to be? It is going to be this exact same. 1, 2, 3, 4, 5, 6. Okay? Got it? So there's one thing I've noticed that, I think you've also noticed that I can say that A union, this all is equal to set C. Isn't it? Like in the last we're going to get this solution, and actually set C is equal to all the elements that we have. So I can say that this is all equal to set C. Okay, now the second one we have is going to be the union of set A and B, then the union of set C. Okay, so let's take the same one, and let me just wrap this a little bit. Yeah, okay, now it's going to be. Okay, so now we have A union B, then union C. Okay, so A union B. A union B is actually going to be. Okay, A union B we have is 1, 2, and 2, 3, 4. So which is going to be the elements 1, 2, 3, 4. Then union of set C, and in set C we have 1, 2, 3, 4, 5, 6 as their elements. Okay, so what is going to be the union set of it? So like we're going to write it only once. So in the end we're going to get the elements 1, 2, 3, 4, 5, and 6. That's it. So you can see the answer is actually equal. Doesn't matter to the we put it together. That doesn't matter. It's from associative law. So we can see that. We can clearly see that it's like second property is also true. Okay, well these all are going to be true, but just to show you, just like we're proving. So the third one we're gonna have is going to be a little bit different. Okay, it's in this third one, in this third property we're gonna have phi, which means that set A union phi is equal to set A. Okay, just have a look. A union phi is equal to set A. How is it possible? From which property is it? Like which property it is exactly trying to tell us? So it is actually the law of identity element. Law of identity element. So I can say that phi is the identity of U. Set U, we have set U is the universal set. So it is the identity, phi is the identity of universal set. Okay, let me write it in bracket. So, law of identity element, and we can see that phi is the identity of U. We have universal set. Got it? Okay, so let's move on to our next topic. Next property we have. Fourth property, okay. Fourth property is going to be like A union A is equal to A. So the fourth property we have is from actually idempotent law. Idempotent law. Do you know about this law? I think you know, and if you don't know that, that doesn't matter. Okay, so in which it is saying, it is trying to tell us that A union A. So you know, union of set A with itself is gonna be actually a set A. So idempotent law, you know, according to this law, universal intersection. So I can say intersection union of any set, of any set with itself revert this same set. Like we can see. Intersection, whether it is intersection or union of any set with itself revert the same set. So A union A is equals to A, and I can say A intersection A is equals to set A. Okay, now our fifth property that I'm going to write, right here, okay. Fifth property that we're gonna write is going to be a little bit same with it. So it's like basically same, in which we're going to use universal set. So universal set, so set U, so U union A is equal to U. U union A is equals to U. And it is from actually the law of universal set. Law of set U, which we have as universal set. So in this one we have is like the universal set. So the union of universal set and set A is equal to the universal set, and it is from the law of universal set. So you know, it is through the law of universal set. So those were some properties, you know, of the operation of union sets, and I hope union of sets is clear to you. And like I would like to say, that's all for today, and see you in the next video. So thanks for watching and have a great day.